Welcome to qnawire.
Question 93, Part A, asks us to calculate the mass of lithium formed by electrolysis of molten lithium chloride. And get my pointer back. So I have molten lithium chloride, and it's gonna go through electrolysis, and the current is going to be equal to 7.5 times 10 to the fourth amps, and it will be flowing for a period of 24 hours. And I'm going to assume that there's an 85% efficiency. Meaning I'm only going to get 85% of the mass that I expect I should get. So it's kind of similar to a percent yield in terms of chemistry. So I'm going to start with my current. If you remember, think about it this way: that an amp is equal to a coulomb per second. That'll help us with our units. So I'm going to start with my amperage here, and I've got 7.5 times 10 to the fourth, and again I'm going to rewrite that as coulombs per second. And I tend to do my problems on big long train tracks, but each one of these is just a fraction multiplied by the one before it. So I'm going to first start by trying to cancel out that time issue there. So I've got seconds on the bottom, and I know I've got 24 hours. So I'm going to need to be canceling time. Obviously, they don't cancel yet. I need to convert hours to seconds. So I can say that 1 hour is equal to 3,600 seconds. And so now seconds cancel and my hours cancel. And so now I just have coulombs. And then the connection between coulombs and your element, mass or whatever else you're trying to find your element, is Faraday's constant. So I'm going to say that 96,485 coulombs per 1 mole of electrons. That's really always the connection that you're going to use. That constant, Faraday's constant, is how you get from current over to the element itself. Now I have lithium, and I'm trying to electrolyze that to make solid lithium. So that would be lithium is a +1 charge, +1 electron is going to take me to the lithium metal. So the number of electrons I have here for every 1 lithium is I have 1 electron. So I can say I have 1 mole of electrons for every 1 mole of lithium. And you're going to get that number from your balanced reaction. And then I can go to mass. I can say that for every 1 mole of lithium, the molar mass is 6.95 grams of lithium. And then I only have an 85% efficiency. So I'm going to be multiplying that by 0.85 because I'm only going to get 0.85 of the amount that I expected I should get. So 85%. So I have my moles of electrons cancel moles of electrons, my coulombs cancel my coulombs, moles of lithium, and I'm left with my mass of lithium. So you plug all that into your calculator and you get 4.0 times 10 to the fifth grams of lithium. That's part A. In part B, we are asked what is the minimum voltage required to drive the reaction. So voltage, let's look at what a volt is. A volt is equal to a joule per coulomb. And so that just to get an idea of what that is here. But I'm going to be taking a look at the cell EMF here. I know that going lithium plus an electron goes to lithium. If you look that up in table E, appendix E, you're going to find that has a naught of negative 3.05 volts. And so that would be my reduction reaction. So my oxidation reaction would be the chloride. It's written as a reduction reaction in the table, right? But it would actually be going the other way. It was my oxidation, and that has an E naught equal to 1.36 volts. And so because it's electrolysis, so normally we say the E cell is equal to the E reduction minus the E oxidation. Because if that number is positive when we subtract that way, then that is going to be a spontaneous reaction. But this is not a spontaneous reaction. This is not a voltaic cell. This is electrolysis. I know it's not spontaneous. That's the definition of electrolysis. You have to add energy. So I'm going to switch my reaction and say the E cell in this case, or the EMF, is going to be equal to the E of the oxidation minus the potential of the reduction. And so my oxidation reaction, again, was the chloride reaction. So that's 1.36 minus the reduction, which was negative 3.05 volts. So the minimum that I would have to have is at least 4.41 volts.